I felt it was valuable to set the stage, sort of looking at the reality, or what I sort of deem as the reality of product development. What you as companies might experience, certainly in your own companies. I'm generalizing it in this case, but it'll help serve the purpose of showing and introducing Creo Simulate, providing an overview, and then sort of showcasing the benefits. We'll then look at a demonstration where I'll sort of go through a number of different capabilities in regards to Creo Simulate. Again, these are sort of general examples, but hopefully you'll be able to extend that to how you could potentially use it in your organization. And then last but not least, I'd like to sort of finish off with discussing a little bit about the technology. So we're talking about the product, and then we're going to talk about the underlying technology, because that's truly what differentiates Creo Simulate from other, FEA tools that are on the market today. Okay. So the first thing I want to look at, again, sort of generalizing it, today's reality. And again, as companies, you're always trying to what? You're trying to get, to market quicker with a superior design. How you develop your product today, how do you get that to market quicker, to beat the competition, and then from a superior design perspective, how do you have options within your solution product that, differentiate itself from, the competition. You also are focused on high quality, making sure that the product that you provide is not going to violate any standards or any liability or any warranty concerns. That it is a high quality product that you're delivering to the market, but with the same time stating that, delivering it, and we're saying not at any cost. You want to optimize how you develop and distribute your product with high quality, but not, break the bank in order to do that. You also want to, sort of continue to reduce overall costs. And again, developing a high-quality product and reduce costs kind of contradict one another and are battling against one another, and looking at a way to optimize that. And that could be optimizing around how you manufacture it, maybe optimizing around the overall materials that are used. Is there a better material, cheaper material that still would yield high, standards of quality? We then want to look at, okay, well, we could do all that, but the design's not that sophisticated. How do we sort of sprinkle in some sophistication into our design, into our product, that is reducing cost, improving quality, and meeting us, time to market faster? Again, these are all sort of conflicting challenges that, organizations like yourself certainly go through. And many of you may have already solved these, but these are ongoing challenges that, companies need to continue to solve. And so what we're finding, and certainly I'd love to say it was myself to state this, but what we're actually finding is supporting material in the context of the Sim Data report that came out last year, but there was also a CAD Trends 2014 survey that went out recently. And again, these are all sort of supporting the elements that, in order to meet these challenges, to meet this reality, implementing tools, simulation and analysis tools into the design process will help you facilitate those, those challenges. Again, from the simulation and analysis tools, again, reducing the overall designs, the quality, improving quality, reduce cost of prototypes, etc. But really, the question comes down to, if we look at a desired, design process. And again, for me, I'm always trying to help companies look at how to optimize and come out with this desired design process. And we say through this desired design process, implementing these simulation tools, we see that that integrated CAE is throughout the design process, from concept through to, the production. In doing that, we can, ramp up shorter development, cycles, reduce or quicker time to market, deeper understanding of product performance, reduce cycle time, fewer prototypes, etc. Again, this is the desired state, and I think, again, supported by these reports that I mentioned earlier. But if we sort of turn the page to what is reality today in what we see in customers, and not to say this is across the board what we see, but in many cases we do see this. If this is the desired state, in reality what we see is this type of scenario. In regards to simulation tools, as I mentioned, that the Sim Data report said integrating that Sim tool into the design process will help yield and improve and meet those challenges. But what we see in regards to this is that companies that do implement a simulation tool don't do it across the board. They focus on sort of where it traditionally was in years past, and that is at the validation phase. So we say here that most companies only leverage the simulation, for design optimization, verification, and validation. Again, this was proven in those reports that I mentioned earlier. We also see that many companies, rely heavily on those physical prototypes. Again, this kind of contradicts what, the companies are trying to adopt, and hopefully, many of you have, but as I said, I think the majority are sort of dealing with these scenarios. We also see the challenge that, from a validation standpoint, that it really is not aligned with the overall design process, that it's really a separate, entity outside of the design process. And in fact, the design process or the design phase is actually extended, to support this separated, separated validation phase. And because it's separated, typically it's, obviously disjointed. It's a separate individual or group of individuals performing these tasks, and those in the design phase are waiting for them to finish their validation in order for them to continue on and potentially produce it. Now, also in many cases, we find that companies just simply can't afford to hire an individual, a PhD type of analyst, and so in a lot of times, again, they rely heavily on the actual prototype as their validation phase. Lastly, we also see that those that are in the validation phase leverage, traditional CAE tools. And the perception in the marketplace is that these tools are hard to use. They are focused solely on the analyst, and they're not easily transferable to those that are in the design phase. And for that reason, this disjointed, design process is typically what we see. And so the consequences of this, as we could probably already assume, limited support for that current design and analysis phase, inability to gain early confidence and mitigate risks. So we're waiting for that analyst to validate it before we actually determine, is it going to, have a high degree of quality. And again, late in the design phase, certainly increases the cost of the actual process, but overall, obviously the ability to create prototypes which are heavily used to, again, validate. And then, high cost of resolving those design flaws that are found late in the design process. We have to go back to the design phase and actually make those changes. And again, finding those late in the design process, as shown on this sort of simple graph, again, later in the design process, the cost of change is certainly a lot higher. And again, for you users and individuals on the line, you probably can, reflect, this truth in consequences of changes that might take place in your business late in the design phase. So really the question is, if we're looking at creating an analysis product or looking at creating simulation throughout the design process, really the question is, how do companies achieve that desired design process? But more importantly, how do we take that simulation product and sort of spread it across the board from concept through to manufacturing? And really it comes down to a number of points, and these are going to be supported by how PTC is introducing Creo Simulate. The first and foremost is this concept of integration and ease of use. Really it boils down that it just can't be an appearance, but it needs to be truly integrated into the workflow, into the model concepts, but more importantly into data management. That it can't be this separated phase that takes place in an organization. It needs to be done, in theory, from concept through to manufacturing. And because you as a business hopefully are leveraging a data management tool in the case of Windshield, how do you connect and utilize the data managed in Windshield but still do the simulation and analysis on that? Again, that integration and then certainly the ease of use is key in that regards. The next item is scalability. That the solution needs to be scalable based upon the user that's using it. We say that it's easy to use, but it needs to be scalable as well. So that if you are simply doing a basic analysis, it should be able to satisfy that need. But if you're an analyst doing a very complex analysis, it should be able to satisfy that need as well. So having a robust environment and capability set is needed in regards to having a fully integrated simulation solution in your product development process. But more importantly, also direct links to third-party development solutions. So if in your business you are using other CAE tools, the likes of let's say Nastran or ANSYS, how are you able to easily connect to those solutions? So this solution that we're proposing and certainly talking about today, has these capabilities. The next one is accuracy. It just can't be enough to have an answer. We need to have the right answer and have the confidence that what you are finding is the right solution. This is more important when we talk about a scalable solution. So if we have someone in the design phase or the concept phase that might not be fully in tune with the FEA, principles and may have not gone to school for those, to be an analyst, they may be a little, they may just not have the necessary knowledge of an analyst. And for that reason, their confidence in the solution that they get needs to be, 100%. And so having an accurate solution produced in, within this simulation environment is essential. We talk about, or certainly you could say, well, Mark, certainly all these other tools and other potential tools that are in the marketplace do this type of capability. They're integrated, they're scalable, they're accurate. But, really when I look at a designer-based FEA application, and really that's what we're talking about, is creating an application not just for the analyst, but for the whole design process, and I sort of dubbed that as the designer-based FEA. But the point I want to make is it can't be solely based on these items, simplified code. Well, if it's going to be for someone that is not trained as an analyst, let's just simplify it. Let's only allow them to do the basic capability. Well, that sort of violates the scalable item that I mentioned at the beginning. Simply providing a simple or light or dumbed down version of a solution is not enough. We need to have it scalable, but be scalable based upon the user's needs to perform the action, being defined. The second item is GUI wizard. Well, it's just, I think this is a common misconception that in order to make it easy to use, just slap a GUI on it, and now it's easy. And that's not necessarily true. And we've seen that in a number of competitive solutions that provide a scroll wheel to say, okay, well, in order to analyze this part, we have the scroll wheel that's going to allow us to change the mesh to be a very fine or a very coarse mesh, and we'll let you get your answers. Well, are the answers right if it's coarse or if it's fine? We don't know, and simply providing a GUI is not going to make the answers, good or bad. And so that's again a misinterpretation. Workflow type. Well, let's just group things together and let them use that. Or if we look at, let's put it on the cloud. These are terms that we hear from, the competitive landscape around how to provide a designer-based FEA. And I'm just simply saying that one or two or three of these is not enough. You need to have a tool that is integrated, scalable, and accurate. And in our regards, I truly believe PTC has that solution in the form of Creo Simulate. So let's go take a look at Creo Simulate since we're moving into that area. As far as a product, we have a full breadth that is scalable, capability. We do that not just as a static analysis, but we do everything from a structural analysis where we're looking at the overall integrity of a part or of an assembly and looking at the real-world, conditions, applying the loads, applying the constraints, and seeing how it's going to perform in regards to those conditions. That can either be a linear analysis, where we sort of look at having a constant stress and strain solution, or it could also look at a non-linear scenario where we're actually going beyond the yield point of a particular material and looking at potentially how it can be permanently deformed. We also look at performing thermal analysis, where we look at the the effects of temperature on our product. And then by combining thermal and structural together, we can determine the overall stresses and deformation as a result. We also look at sort of, I won't say advanced, but additional analysis types from modal, buckling, and dynamic. Again, these are all there as an option for users to be able to address the need of the design, the part, the assembly, of what they're going to be analyzing, from a concept through design, through validation, before we actually get to the manufacturing piece. Creo Simulate is offered in two flavors, and this was introduced with, with Creo, as launching with Creo 1.0. With that release of Creo 1.0, we are all about this idea of creating a scalable set of applications that are geared towards a specific user, at the right time scenario. So these any role app solutions that we've been talking about. If you're familiar with Creo Parametric, Creo Simulate in regards is a standalone application that is geared around individuals that are solely focused on performing, simulation activities on their geometry. But we also have it integrated into Creo Parametric. And so in these two areas, or in these two scenarios, individuals that are using Creo Parametric today, and if they have a Creo Simulate extension, can log in or launch, Creo Simulate internally to Creo Parametric, and then perform those, simulation exercises. And again, if you're an individual solely focused on Creo Simulate, and you may not be a CAD expert, an analyst in this case, you can utilize the standalone application of Creo Simulate to perform the analysis, on the given models that, the design folks are giving you. So let's look at the product family. We talk about the capabilities, structural, thermal, etc. We talk about the different apps, but then we look at how we are offering it. What is available to you as a customer? And again, we talk about scalability here. So out of the box, we have this concept of Creo Simulate Lite, which means every seat of Creo Parametric or every seat of Creo installed could have Creo Simulate Lite installed as well. Creo Simulate Lite is a free offering. There's no cost to that. There are some limitations, which I'll talk about in a moment, but this allows any individual that has a Creo license, active Creo license, to be able to run Creo Simulate, in this case in the Lite form. But then what we have is two other extensions. We have the initial extension called Creo Simulate extension, which I'll go into in a moment, which is a full-functioning linear FEA package. And then we have, for those that are looking to go beyond linear, look at sort of the dynamics and nonlinear aspects of their designs, models, what have you, we have the advanced simulation extension. Again, it bridges that gap from doing the linear to the nonlinear scenario. And again, we'll go into details in this in a moment. Last but not least is we have this idea of the Fatigue Advisor extension. Again, this is a separate extension that companies can acquire, but the purpose of this is to evaluate the reliability, the durability, the life of a particular product. So if your product is going to be, going through movement or performing some, operation, how many cycles through that operation will your product, based on its current design, can go through before it breaks? And so this Fatigue Advisor will allow you to evaluate how many cycles. Is it 100,000? Is it 1,000,000 cycles before your part can break? And as a result of that, you can may choose to improve your design or not. So let's go take a look at the Lite solution. Again, the Lite solution, as I mentioned, is freely available for anyone that has a Creo Parametric license. The requirement is that when you do the installation, you do need to install Creo Simulate. And you may say, well, we don't have a Simulate license. That's fine. You would still install Creo Simulate along with Creo Parametric. And as a result, if you don't have a Creo Simulate license extension or the advanced extension, you will access the Lite option. And I'll show this in a moment. But what the Lite capability will do is still allow you to walk through the process of performing an analysis. It takes you through the process of defining your materials, your constraints, your loads, and then actually running it and reviewing the results. If you see it from this menu on the screen here, the toolbar, which we'll look at in a moment, is grayed out. And what we're going to use is this process guide. But the point here is that you are able to do it on parts and assemblies, but there is a limitation of 200 surfaces. But at least it'll give you a sense of what simulation is all about and allow you to analyze the parts and assemblies, under that 200 surface limit and still get, proper results that are being generated for you. The next stage that we're looking at is this whole Creo Simulate extension. And this is looking at, doing that linear analysis where we can do static analysis where we can apply contact but without friction. But we can do the static analysis looking at the overall deformation, the stresses, the strains applied to our design based upon the conditions that we apply. And we'll see this in an example in a moment. We can do our modal and buckling analysis. We can also do a steady-state thermal analysis on our design. We do have a degree of optimization capabilities, which I'll demonstrate for you in a moment, and then different types of sort of what we call simulation definitions, where we want to then apply springs, we want to apply, create beams, we want to, provide, create fasteners or what have you. So we can do some definition of the design in the simulation extension license, which will still allow us to do our analysis, but again, keeping in mind this is a linear analysis. We then move to the next phase of where we talk about advanced, and this is sort of jumping the gap now from linear to nonlinear, where we now explore additional capabilities of our design, where we are now looking at the idea of contact now with infinite friction. And as a little tidbit here in the release of 3.0 that is going to be coming out in the next month is the idea of now doing finite friction, where we can now actually apply those frictions. So the advanced license capability will allow for that. But really what we're doing is understanding our model through large displacement or a large deformation, how it's going to be going beyond the elastic region and actually going into a plastic region where a large deformation is taking place. And in most cases, the deformation will not go back to its original form because of, again, the nonlinear properties that are taking place. Okay? But we can do dynamic. We can do now a transient versus a steady state. We can do a transient thermal analysis. And we're also now looking at the different materials. Traditionally, it was an isotropic linear material, but now we could bring in additional types of materials where we look at hyperelastic or elastoplastic materials that really, in the case of rubber, for example, which is a hyperelastic material, and we can actually understand the effects of that in our design. Typically our designs aren't linear, so having the capability to analyze it in a nonlinear fashion is certainly suitable. And then last is the fatigue advisor, which I talked about earlier, which goes through the overall life of your product, looking at, understanding how many cycles will my product go through before it breaks, where is it going to break, and then what could you as a designer need to do to go back and make those changes in order to improve the overall, life of your product. Okay? So let's sort of step back a little bit and look at sort of this traditional, typical simulation process. It's probably worthwhile to go through this for you as either engineers or designers and may not be analysts to understand what's the process. You showed me a lot, Mark, but it may be a little overwhelming. Let's sort of look at how we would go through this process, and hopefully this sort of brings it to a range that it sort of makes sense on how you could use this in your business. So in this case, we talk about having the model definition. This is what you've spent the time on creating your model in Creo Parametric. And I kind of talk about this as sort of as one of the 4 sort of steps in a simulation process. So step 1 is define your model. Create your extrusions, your revolves, your rounds, etc. We then are going to go into Creo Simulate, where we talk about pre-processing, where we want to now apply material. We want to define things like our displacements, our forces. We may actually even want to create some probe measures, where I actually want to analyze stress or strain, or what the force is, or what have you, applied to your model as it's going through its simulation. That's what we would refer to as measures. So we would apply this in this pre-processing phase. And in many cases, we might actually also go ahead and mesh our model just to see the types of elements that are created. Once we do this, we then want to set up our analysis. And again, it's here that we determine the type of analysis that you want to run. Is it going to be a static analysis? Is it going to be a thermal analysis? Is it going to be a buckling analysis, fatigue analysis, whatever the case may be? Once you determine the right analysis you're going to run, in this case, on the image it's showing a static analysis, you're going to run it, and then the results are going to be shown to you. And once you review the results, you'd be able to identify, in this case, it's showing stresses, where the high stress, low stress areas are, You could then go in and analyze that further, understanding what those stresses are. Has it violated the particular material that you're using? Should it be in the range that it should be? And then as a result of that, you could go back to the model definition, make your changes, and then walk through this process again. Now, I talk about this optional fifth step, and this is the idea of sort of doing design variation and optimization. Not a lot of companies, may take advantage of that. I would strongly say you may want to look at it because it adds a lot of value to you, certainly to your business. And this looks at understanding the results, and then based on a range, be able to put these design variables in, and then have the system optimize it to minimize the given stress in the model, or minimize the displacement. Minimize something where your model then will have those dimensions change and meet the needs of the goal, in this case of minimizing the stress or minimizing the deformation. We'll take a look at that in an example as well. Okay, so now that sort of I talk about the product, I talk about the packages, I talk a little bit about the process, let's actually jump into Creo Simulate and take a look at this directly. So on my screen is Creo Parametric. I'm going to run it with Creo Simulate integrated into Creo Parametric. If I just launched Creo Simulate by itself, which I have an icon on my desktop, it would look exactly like this, but I would see Creo Simulate up at the top, and my menus would then only showcase the icons corresponding to Creo Simulate. But in this case, what I want to do is let's go open up a simple bracket. I want to start off sort of simple, and then we'll sort of move up in levels of complexity with these given examples. So the first item that we're going to look at, and for those of you that may have seen some demos in the past, we've used this model before, but it's a great model just to show the process. And so in this case, we have this shelf bracket that we're obviously going to have a shelf on top, and it's going to have some applied load on it that's going to have some results or some impact on this overall shape. So what we want to do is we want to simply go into our simulate model. We have the model definition done. That was at step 1 that we looked at. So I'm going to click on application, and I'm going to click on simulate. So immediately it changes my environment into our simulate mode, where again I have my given icons, given tabs pertaining to Creo Simulate. I want to stop here for a moment, though, and just simply state, if you have installed, as I mentioned at the beginning, installed Creo Parametric and Creo Simulate, but you don't have a Simulate license, these menus are going to be grayed out, and you're going to be running the light mode. And what you would see is, and I'll go into this mode right now, you're going to be jumping into Creo Simulate Light, and you're going to see this process guide. And again, this process guide will walk you through, okay, let's click on Next. Next says, okay, you must assign a material. So then you can click on Assign. You go assign your material. Next. Okay, add your constraints. Add your loads, analysis, and then view your results. This process guide will take you through step by step in order to, as I said, define and constrain your model, and then run the results and see the, certainly see the results for you. So a great little exercise that you can go through if you don't have the Simulate license. But what we want to look at is the overall process that we do have a Simulate license, and as a result, I do have my menus and options available to me up at the top. You're going to see that there are 2 elements. We have a structure mode, and we also have a thermal mode. And again, if I go in my thermal mode, I'm going to have different icons and capabilities for me. In the case of loads, where I can apply a heat load, and then the boundary conditions from either a prescribed temperature, convection condition, radiation condition as well. Okay. For this example, we're simply going to go through a structure mode. Again, in this case, I've got applied loads, such as a force, pressure, bearing, etc. And I have my constraints in regards to displacement, planar, pin, or ball. Again, trying to sort of make it self-explanatory on what those are. Then we have our materials, and then we're going to run our design studies. So again, looking at what we saw in that slide is we want to first and foremost is, apply our materials. Right now, I don't have an applied material for this. If I had applied the material in Creo Parametric, it would be carried over into here. We use the same material database. But in this case, what I want to do is assign my material of steel. And immediately I get an icon pertaining to steel for this particular object. Now what I want to do is go apply my displacements. So when I say I want to create a displacement, it's not going to be a plane or a pin or a ball. And again, those are pertaining to specific geometry in particular. If I've got, let's say, a bolt holding this against the wall, maybe I would use a pin constraint. In this regard, I'm simply going to look at doing a displacement. And in my dialog, I can now define both translation and rotation. In this case, I want the translation defined. And by default, everything is shown as fixed based on X, Y, and Z. Let's actually go turn on our triad at the bottom so I can actually see my location accordingly. What I want to do is I actually want to select the top, and I want to select the bottom. And I want to set those as fixed. These aren't moving. This is now going to be stuck into place, and something else is going to happen to my model that will actually cause some deformation to take place. Okay? The next thing I want to do is now apply my force. Now again, just like we saw with our constraints, I get a new dialog that is presented to me where I can define the forces and or the moments depending upon the condition. In this case, I actually want to apply a negative 20 pounds force, and if I look at my triad, it's moving in, I want to move down, so it's going to move in the negative Y direction. And I would go ahead now in, if I select the geometry, so we're going to select these two cylindrical surfaces. And if I go click on preview, it's going to show me the direction of that force, in this case, in a negative direction of 20 pounds force. But in reality, that's not how this shelf is going to be loaded. That would be the case if the load was right above, but we're going to assume the load is going to be applied somewhere out here, and we want to see what the result of the load being pushed or forced at this particular point is going to have on these two surfaces that I selected. So we can go into looking at things under advanced, and I'm actually going to control the distribution, and I want to control it as total load at point. And I want to control it at this point, these forces at this particular point. And if I preview this, I get this sort of definition. Again, it's looking at what the effects on this top surface is about this point in the negative 20 direction, 20 pounds force in the Y direction, and then we see on the bottom surface. So that's the result that we want to look at. Now that I've defined my constraints, my loads, my material, I'm really done, and I can now start the analysis process. At this point, I'm going to create a new static analysis. And in my dialog, I could say, give it a name, just we'll say static. We'll say initial. And then what we have here is we're going to run it with the constraints defined and then the loads defined. And then we're also going to run it under my convergence with either a single, multi, or quick check. By default, we'll probably run it as a single pass. And this is sort of the underlying algorithms, or what we call the solver within Creo Simulate, that sort of optimizes the solution. It's going to run it once, and then it's going to run it a second time in this process to optimize the underlying elements to correspond with getting the most accurate answer possible. So at this point, what we'll do is we'll click on OK, and then we'll go run this analysis. Now, it actually ran through it relatively quickly, and as soon as we're finished, it's going to give us our diagnostic window. And the diagnostic window for individuals that may not be analyst experts is going to give you critical information about your analysis. In this case, it's saying everything is blue as a blue dot, which means everything is 100% complete and satisfied. If there were some warnings or potential errors, we'll actually see those results in here as well, and it'll give you clues on what you need to do to actually go fix your design. We can also then look at what we call our study status, and this actually goes into the details of what actually took place in the analysis. It went through the initial pass, it went through the second pass to verify, and then it looked at the overall mass of what the object was, and the overall measures. So in this case, looking at the different, for example, the maximum stress that might be applied to this object. Okay? So those are the results in a text form. But let's go actually look at the results in a graphics window. And this is our post-processing in our results window. And again, we can review our results either on one-on-one, or we can actually use a defined template, which I've used here, that will now show the overall deformed and animated stresses of the von Mises, or I can look at the displacement magnitude, or in this case, I can look at the stress vectors. And again, this is giving me information about my design, pertaining to the analysis that we just ran. Let's go take a look at this particular one in question. And let's go ahead and turn off our animation. I want to see just fully deformed. Here we are. So as a result, this is showing me my definition, and I'm seeing some analysis issues here. And in this case, it's showing me that I've got a high stress area, and based on my legend, I can see the high stress area identified at the top. And in fact, I can actually go and say, well, let's go info, and I want to view max. And it'll actually show me what the overall max stress is. In this case, almost 19,000, in this case, pounds per square inch, or 19 kilogram pounds per square inch. That doesn't make sense. Yeah, kilopound per square inch, if it was, obviously in KSI values. Okay? So what we want to look at here is, we want to modify that. And then if I actually go look at my displacements, let's go click on displacement, and I want it in inches. And again, let's show deformed. It's showing a maximum displacement of 0.0020 almost inches. And so based on my design, these aren't right. I want to actually go change this. This is going to violate my, the quality of my model. There's going to be some problems here. It may actually go beyond the strength of the material in question. And so what we want to do is go optimize this. We want to go make a change. Now, as I mentioned, using this in the design phase, we can always go back into Creo Parametric. We could make those changes to our model, maybe change the round, maybe go change the different geometry. But we actually want to leverage that fifth option that was optional in that slide that I showed you. And this is the idea that we're going to run, and I just did this, open this up just because it does take a little time to run. But I'm going to show you how you can use an optimization and actually have your model update and run an analysis at every phase to come out with an optimized solution to meet the needs of the particular bracket in this case. So here's that static analysis that I ran initially on that other example, but let me go double click on this optimized study definition. And as an FYI, if I click on File New, I've got all my sensitivity design studies. If I'm looking at a specific dimension and I want to see what the effects of that dimension, if I modify it over, in regards to stress or deformation or something. In this case, though, I want to run an optimization which allows me to enter in a number of variables with its current form, and then I have the minimum and maximum, and I actually want to let simulation based on some design limits. In this case, I'm saying a maximum stress and a maximum displacement, and I apply the values. So in this case, it's going to be 11 KSI. In the last example, we saw it was at almost 20. So I want to reduce the overall stress. At the same time, I want to minimize the overall displacement. And because we enter in these values, I can now run that analysis, and it will go solve the analysis. If I go look at the phases, it's going to go through each phase, changing the various dimensions to see if we've now maintained or are able to meet the needs of the overall goals that I set forth. Once the analysis is done, again, it'll tell us that it's complete. It'll give us the duration and all the pertinent information. And in fact, we can also go back in and see what the change the dimensions are. But we can go in here and say, well, let's go take a look at the optimized history. And this will actually show you the different steps that it went through to get to the given result that we see on the screen. Let me close this. We could then go view these results. So let's go look at stress. Let's go to our KSI as a value. And then let's go to continuous tone. I could also set up a config option to have this automatically selected. So there's our new defined shape. Well, we can also then go say, well, let's go look at the initial phase step then so that we can do some comparison. Turn up 15, let me show the comparison. Now we see that the max stress on the initial part was about 19 KSI. Now the new optimized is underneath that variable of, it says it needs to be within the range of 11 or less. And now we have 11. We see 0.0006. Again, because of our tolerance range, it certainly was it's within tolerance. And then we can also look at going back into here. We can then, hey, let's go take a look at our displacement. And we can go back to the other initial window, and we can do the same. Let's go to our displacement. And again, we could see the differences in this case. So I could have gone back into Creo Parametric and made those changes and then go back in and rerun the analysis and see the new results. But using the optimization sort of takes the steps, you know, and automates it for me as an engineer, saving me time certainly in this effort. If this is not the shape that you want, then you can go back and make those changes and see what the results are. But again, that optimization is real quick and easy to do. Okay? So that's sort of what we sort of deem as traditional linear analysis. The next item that I want to take a look at is more the nonlinear scenario. So the nonlinear scenario is going to be a little different, where we're now actually going to look at this model of a rubber stopper. So this is what you might see on the bottom of some machinery, equipment, or what have you. You know, on the bottom of a desk, whatever the case may be. What you want to understand is if I apply a load on the top of this part as it's pushing, what is happening to this rubber stopper? You know, how is it deforming? Where's the range of which it's going to deform to before it fractures and breaks? And then what is the overall stress as I apply more force? What's going to be the stress and the issues on this top part that I need to be aware of? And based on this design, as I'm pushing it down, I might see some things happen. So we're looking at a material property now which is not linear. It's going to be hyperelastic, which is a nonlinear material. So we're going to set that for this particular object, and then we're going to run it through a large deformation analysis with contacts and you know, what have you. So let's click on Application, Simulate. It immediately brings us back into our simulate environment. Now the thing that I'm setting up here is, if I click on Model Setup, I've set the model setup to do a 2D asymmetric. I'm not doing it as a 3D. And the reasons why I'm not doing that as a 3D is because it's a symmetrical object. It makes it easy. I could just do a slice and analyze the slice. The second thing, though, that makes it valuable is it also reduces the amount of time it takes to do the actual analysis. So we want to be smart and optimize, especially as we're, you know, trying to make changes and figure out what are the effects early, you know, in the design process. I want to be able to do that as quick as possible, get my results, make my changes, and then move on with the design. And so we need to be able to do that efficiently. So the first thing I want to look at in this case is I want to click on, well, let me expand this just so I could summarize it. You know, I've got a defined material that I have as sort of this steel. If I go look at the definition, it's telling me that it's a structural, isometric, linear material with defined, you know, Young's modulus and all the definitions of the material property. If I go look at rubber, we're actually going to look at, and you'll notice that it's not an isotropic linear. It's actually now a hyperelastic material. And you'll also see that the material model, I also have this ability to click on Edit, where I can actually input the stress and strain of my particular material. And this might be results that you have from the lab. You know that the stress and the strain on your defined material is not off the shelf. It's unique to you. You may be able to input the stress and strain and define the overall material curve, you know, based on some particular law. In this case, we're using this polynomial order number 2 that is going to define the overall coefficient of thermal expansion in regards to this material and all the variables pertaining to that definition of that material. Again, all based on the lab results of stress and strain. At this point, I'm going to click on OK. And that's my rubber, and then we're defining steel. And then the only other thing that I'm looking at here is looking at the a connection between these two objects. So it's going to be connected or will come into contact with one another. And then I've also defined my overall loads, where I have a constraint up at the top and I have a constraint at the bottom. But instead of using it as a force, I'm defining it as a prescribed distance. So I'm saying that this is going to move negative direction of 9 millimeters. Now when we run the result, again, I've already run this just because it takes a little time, we can now view the results of this as it's going through its range of motion. So let's do displacement first, and I want to do continuous tone. We'll do deformed, and for argument's sake, we'll put on animation. So now what we'll see is we'll see this object move that 9 millimeters in the negative direction down, and we'll see the effects of the displacement and the overall bowing out of that rubber stopper. Let's go now take a look at, maybe not displacement, let's go look at stress. Let me walk through this so we can see it. We can now see the resulting stress of what's happening with the rubber as we're compressing it. It's now applying stress on this upper part. We see the high stress in this arc or in this fillet, and then we certainly see it at the bottom of the particular stopper, plunger at the top. Now, right now, this is showing me a max stress, and again, we could go view the max stress, not in animation. Let me go turn off animation. I want to view the mass. We could go view the view max, and we see the max is right at this corner, where we're going to have a high stress in this corner. We're going to also see some stress values here. But we see very little stress in the rubber stopper just because we're compressing it. But we can go in and actually go modify the legend. So let me go modify the legend here. Start at the bottom. Let me put in a value of, we'll do 0. And then I'm going to apply the top, and we'll do, say, 45. In fact, let's change that to 20. Once I change the stress, I can now see I'm really concentrating the range of my graph. But what we are seeing now is the high degree, or in the context of what is the stress inside the rubber, we can see the actual concentration of that in our object. We see the plunger at the top all in red because it's above the 20, the 20 megapascals. But again, we've only done this change of the range just so I could see what the actual stress distribution is on the inside of the rubber. But if we go back to the original graph or the original legend, again, the stress inside the rubber is so small in comparison to what it is on the top. At this point, I might go in and say, well, maybe we want to modify the radius. Maybe I want to change the shape, size, whatever the case may be pertaining to this. But this is a large deformation, a nonlinear analysis, mainly because we're using the material, in this case hyperelastic material, but this is going through a nonlinear analysis in this case, nonlinear analysis in this case. Okay? So I have another example, but just because we're short on time, I just want to just summarize on some of the key differentiators and why Creo Simulate is valuable, and then Scott, I'll hand it back over to you. Is first and foremost ease of use. Common, consistent UI. Let me go into slide mode here. Is that we have a constant UI built on the whole Creo platform, right mouse button capabilities, the ribbon. Everything is familiar to you based on your use of Creo Parametric, in this case, in Creo Simulate. We also have the underlying elements of the common data model. Everything is based upon, the common data model. A model created in one application can easily be opened in another Creo app. This is no different in the context of Creo Simulate. But more importantly is the stuff that you save to your geometry is going to be saved back to the part file or the assembly file to be leveraged by others that are using the particular model in that case. But more importantly, at the end of the day, it's the accuracy and reliability of the application or solution. And it really comes down to the underlying technology and how we differentiate from other solutions. Traditionally, most CAE tools use this concept of H element, which uses a linear element structure. We don't use that. We use this P element technology, which is a higher order polynomial solution, mathematical system for each element in our design. Well, Mark, why is that important? Really, what that does is it allows the model or the mesh or the simulation to adhere to the change that you take place in your design. So it auto-creates the mesh for you. If you notice, when I ran those analyses, I didn't create a mesh. When I ran the analysis, the mesh was automatically created for me. And based upon the P levels or the polynomial class level, it will meet the needs of those particular areas. We also have this concept of adaptive refinement. So when I run my analysis, it's going to look at each element and what is the stresses on each element in my design. And what it's going to do is it's going to refine the polynomial value for each element in order to get the most accurate result. The P values range from 1 to 9, and it will change each element pertaining to where the high stresses are automatically for you. So this is the idea of adaptive refinement capabilities. And then as a result of that, it's going to then converge on a solution. The nice thing is, once you run the mesh once, it's saved in the model. So when you make your change in Creo Parametric to come back, you just simply have to rerun the analysis. You don't have to remesh it or anything like that. Again, the adaptive capability will take into account those changes that need to take place in order for you to converge on a solution. I've got slides on the technology, but just out of interest, I'll just jump through those, and if there are additional questions, then we can answer those. But in summary, the big question, I always get asked is, do I have my CAD designers become analysts, or do I have my analysts become CAD designers? And I'm just saying there could be a nice harmony between this, where the CAD engineers are actually utilizing the tool integrated in Creo Parametric, leveraging the ease of use and the capabilities to apply those conditions and controls and actually quickly analyze their design during that design process, find the issues, make those changes, and then provide to the analyst a more refined, high-quality solution that they don't have to spend the time in order to do. But really, at the end of the day, what are we providing to you as a customer? Again, ease of use for all users. The tool needs to not just simply give you an answer, but give you the right answer. And if it's not the right answer, it should help guide the user in what to do to fix the design in order to make the solution, successful. So again, the idea of educating based on the particular problem being solved. Robust and efficient, we talk about the underlying P element technology embedded in the design environment we looked at. It's fundamental. Basically the technology is really geared, and really the only solution that's geared to a designer or an engineer. And that is, again, the adaptive capability that I mentioned earlier. So as you make a change, you don't have to go in and become a surgeon to create the mesh to meet the needs. Scalable, which we talked about, providing the scalable approach to technology based on the needs of that user at that given time. And then at the end of the day, enabling you to, solve your problems early in the design process so that you could then have a more confident solution that gets to the validation phase, to the analyst, or to manufacturing. Reduce the amount of prototypes that you need to do, and then move on with the day to meet those initial challenges that we talked about at the very beginning. Scott, over to you.
Hey, Mark, thanks a whole bunch. We know your time is valuable, and we're glad we could spend it with you. Presentation very thorough. It's so thorough, in fact, we don't have any questions at this point. If you all do think of any questions, please feel free to reach out to your respective TriStar rep. We will make this recording available to all that attended, so be on the lookout in your inboxes for an email with a link to the recording. Just once again, to review, the Creo Simulate promotion is 50% off, and that runs through June 20th on any Creo Simulate product. If you want any more information on this deal or anything else, you all can contact, again, your respective TriStar representative. With that said, the next feature webinar that TriStar will run will be assembly techniques, designing and managing large assemblies in PTC Creo with PTC Project Manager Moshe Baum. And you all can sign up for that at tristar.com/events. Thank you all for joining us, and have a great week.